Hello everyone, I'm Mrittika and this is Malini. We are architects in rack scale and software group within Intel. What we are going to cover today is a new architecture called rack scale design and how we are enabling rack scale design into OpenStack. We are also going to talk about a project called Valence that we have introduced. So if you have not heard about rack scale is evolutionary design for pooled infrastructure. So up until now, or at least a year back, you could buy a server which was a monolithic server, and every time you have to change, you buy the whole server board again. What we intend to do with rack scale is be able to provide pooled instances of compute, pooled instances of memory, storage, and network, all in an environment which could be hosted in a rack. And with the help of software-defined APIs, you should be able to compose a server as and when you need and make it available into your management environment. What that gives us is an ability to disaggregate the resources in a hardware environment so that it does not need to be in a particular form factor, as long as you have a high bandwidth connectivity within the environment. The ability to be able to discover all of this in a form that is programmable, and as and when new components get added to the rack, you're able to discover, you're able to add it to your composed system. The concept of composition or infrastructure that is composed is new in this environment, and hence we realize this is not something cloud deployers or cloud builders are already aware of. And so we have made it easy by providing a standardized API interface. There is DMTF, known for IPMI, SIM, and that kind of management models. There is a new REST API model that has been proposed called RedFish, and some of you may know about it. So we have built this software aligned to RedFish. We actually work with RedFish. We define some of the APIs in RedFish. The idea is, if it is standardized, there are multitude of vendors who can provide to the standardized interface, and then you can compose and deploy as and when you need. So you do not need to have racks of servers filled up, deployed already, even though you do not have workloads to deploy on them. So as and when your workloads increase, number of users increase, you can buy your systems, get them set up, get that all automated, and power on only when you need to deploy more. This is a new project that we have launched called Valence, and I'll ask Malini to go over that.
Okay. Hi. So I'm Malini, colleague of Mrittika's. I just want to point out one more thing with this whole rack scale design. If you get some new kind of memory, you don't have to throw out all that rack. Because it's all disaggregated hardware, you can just bring in your new non-volatile memory, some other kind of SSD, maybe something self-encrypting. So the options are enormous, and this is going to reduce your total cost of ownership. But given this rack is amorphous, you can compose it any which way you want, and that we have a standard API from DMTF called RedFish. Let's see how we can use this in the cloud, okay? And that's how Valence was born, how to consume these APIs easily. So just think what you would like to do with this. Would you want to start a whole cloud from a rack scale pod, a data center like that? Or do you have already some conventional resources and you want to enhance them using a rack? So those are the kind of options, greenfield, brownfield, and that's how we started defining Valence. So Valence, as you see, is the bunch of green things over here. There'll be a web UI to make it easy for you to see a visual representation of things. There'll be an API controller, which pretty much talks in the back end. Where's this little mouse? Pretty much talks in the back end all those RedFish API calls. And when you're talking about an OpenStack cloud, you'll have these plugins. These plugins will, like hook you up into Ironic, so you can say, hey, I need another bare metal machine, but I need it to have a lot of storage because I'm going to launch a gigantic database on it, maybe some SAP kind of data load. So then you want to compose a node on the fly that has a lot of SSD behind it. And that's the sort of things you'll be able to specify through the API controller and launch that node, but then Ironic can then see that node and say, okay, you want that? Here you go ahead, launch it. So the way we envisage Valence is not only this UI and the controller, the API and controller node work, and the plugins, and these plugins that we've mentioned here for OpenStack, but behind the scenes how things happen are the RedFish API calls to this pod manager that's on top, the software layer that's on top of the data center that then communicates to the racks. You can have as many racks as you need, thousands of them if you need. And then even the deployment, we're not restricting you to Fuel or TripleO or Juju, those will all be options. And this is where we'll be inviting you to come and join our community, make these deployment tools work with Valence. How else do we envisage this usage? We envisage a pod, this whole rack scale design, to be something like a resource that you carve up for different clouds. And then you think of it as a utility company. Now you're paying for VMs and containers as you need, but think as a cloud operator paying for resources as they need. You know, I have a tiny cloud today. I don't have any great workloads. I'm still building up my mass and my customer base. I'll have a small cloud. As I need more and I'm connected to a pod, I can ask for more resources on the fly. And let's say there's no workloads happening, I can release resources, save power, save money, etc. So this is go back. We have agnostic to the deployment tool. Today we have things working with TripleO and Juju in our proof of concepts. We even have a Fuel deployment working. So 3 kind of deployments already on the board right now. All RedFish REST API calls. And then the way we see it is multiple clouds coming out of a pod. So what we really need to get on next level is all these plugins into OpenStack for Ironic, for Nova, and think of it as a shrinking and expanding cloud. Okay?
We have a demo. It's at our booth. And so this was, the demo was built within the last 3 weeks, and so we couldn't get a web address going. We would have liked to show you the demo. So if you come down to the marketplace at the Intel booth, the demo is being hosted there on this whole workflow. How does this work? How do we discover? How do we integrate? What does it show up? How do you compose nodes all on the fly? And how do you use it? You deploy and then you see it appear in the OpenStack horizon. And once you see it in OpenStack horizon, how do you go put workloads on it? This, so Valence itself is a community project that we started. We have many partners. We have another discussion tomorrow on this, another brown bag in the morning, where we'll look at an implementation of Valence from one of our partners. The other is that we have lots of folks interested in doing different kinds of things. So if there's pooled infrastructure, how would you want to use it? Somebody may want to use it just to set up and segregate different kinds of accounts. Another one may want to use for add nodes only when there is a load balancer involved and the load balancer says, okay, I'm going to need one and you want to add. So what kind of APIs do you want? So it would be good if there are usages from somebody who wants to use this environment to set up a cloud. Whether there are environments and timings when you're not using the nodes, can you shut it down? You can currently through Ironic do an IPMI call to a regular node and shut down a node. But the time it takes to bring that back up, get it deployed, is something which is needed as an optimization within Ironic. What Valence would do is it will take care of all of this. It will actually keep track of the whole life cycle of the rack. So within the rack, there are nodes which are maybe just added. Just now I've put in a blade, so that's one state. There is another where it's discovered. There is another state where it's booted up but not deployed. Another where it's deployed, it's ready for OpenStack, ready to appear in Horizon. So this whole life cycle of the rack of different kinds of nodes, different capabilities of nodes. So we have Xeons of 3 generations which are possible within a rack with different kinds of features. There are features which are possible in NFV. There are features which are possible in useful in storage. All of these capabilities can be exposed in the form of flavors. So we will have an API for everyone to define flavors. We will have some predefined flavors, and we will have APIs where you can define your own flavor. So for example, if you have NFV workloads which you want to deploy, you actually want to compose nodes which are co-located. Currently, there is no way of figuring out in a environment that you are co-located. And hence we have APIs for telling you, what is the hierarchy of the rack. The RedFish itself has a hierarchy, and so we will have APIs for that. There are other things which are coming up, partitioning of resources, multiple clouds. Do you want to add something?
So as Mrittika already mentioned, these hardware flavors, you can define them. We'll be giving you APIs for that. And sometimes your flavor might say, I want something like quick assist technology for compression, for cryptography. So you can specify all those things that are available in that palette of your rack. What are the capabilities? I wanted this, I wanted that, like a shopping cart. Create those nodes. So we invite you to get involved. Please share with us your use cases. We have about 10 listed on the Valence site on the wiki page, but that's only our imagination, the things we came up with. We'd love to hear more of you, and our partners, and we'd love to hear more from you. And we'd love to have you join us at our meetings. Come see the demo at the Intel booth downstairs. We're eager to hear you.
Join the IRC meetings. And this is an infra project within OpenStack already. So you can get to see the code also. That's all. Thank you.
Thank you.